Hello, my name is Desmond Edagese, and I welcome you to mathematics class. Today we'll be looking at the theme mensuration and geometry. And of course, we know what geometry is all about. Geometry deals with points, lines, curves, surfaces, and generally all kinds of shapes. Well, our topic for today is on plane shapes. So we're going to be learning about all kinds of plane shapes. Let's go into our class. In the course of our class today, I expect that there are certain things we must have learned about. So firstly, we'll get an introduction to what plane shapes are all about. Next, we'll also learn about two-dimensional plane shapes. And of course, we'll get to know some examples of these 2D plane shapes, such as rectangles, squares, triangles, trapeziums, parallelograms, and circle. And finally, we'll learn about the different classification of plane shapes, such as polygons, regular polygons, and we'll also learn about the quadrilaterals. Let's go on. Now, before we go into what we came here to learn today, plane shapes. Plane shapes do not just originate from nowhere. That is, they have somewhere they came from. And let's look at the origin of our plane shapes. Now, the first thing we learn about is the point. If I ask us to draw a point, I know it will be very simple. It's a simple dot. And basically, that's what a point is. Now, a point does not have dimension. It is stationary, as we can see. It does not move in any direction, but has a position. That is what we refer to as a point. Now, as we go on, we also have what we know as a line. A line is the connection between 2 points. So if I connected this point here to another point, I will have a line. And this is an example of a line. Now, we said a point is stationary. Of course, it doesn't move in any direction. It does not have a dimension. But a line has dimension. As we can see, it is moving in an upward direction, this line. It could also be moving in a downward direction. Basically, it has a dimension, but it has just one dimension. So we say a line has what? One dimension. Next, we have a plane. A plane, on the other hand, is two-dimensional. So we don't just have a line, but we also have another line moving in another direction. It has two dimensions. This is an example, for instance, of a plane. It is two-dimensional, as you can see. It has this direction that it moves in, and the other direction that it moves in. Of course, these are also the same dimensions. So we have two dimensions. A plane is two-dimension. It occurs on a flat surface. That is, it does not have a width. So it has just length and breadth. It is two-dimensional. Now let's move on. Next, we have what we refer to as a solid. A solid, on the other hand, has three dimensions. This here is an example of a solid. This could be a packet of biscuits or a box where we keep our clothes. As we can see, it has a line that is moving in this direction. So have another line moving in another direction. That's two dimensions as we count. Then it has a width or depth. Sorry, it has a depth. So we have this dimension, and this dimension. We say it is what? Three-dimensional. And it is a solid. The world in which we live in is basically made up of so many solids if we look around us. So we have things like boxes, cubes, we have cylinders, and all kinds of other solids. All solids are what? Three-dimensional. Well, for our class today, we're going to be focusing on planes. Planes are two-dimensional. As we go further in our class, we'll learn about two-dimensional shapes. Let's go on. Now, in geometry, as we have learned, a plane is a flat surface. Remember, we just talked about that. That has no thickness. It has two dimensions, which is the length and the breadth, but has no thickness. It lies on a flat surface. A plane shape, therefore, is any shape, as you can imagine, that is two-dimensional. It has length and breadth. Because it has length and breadth, we can calculate the surface within such shapes to get an area. But since it has no depth and thickness, we can't calculate volumes for such plane shapes. Two-dimensional shapes can be imagined to be a shape that is always lying on a piece of paper. Now imagine a shape that you draw on a piece of paper. It is flat. It has two dimensions. It does not have what you refer to as thickness. If it does not have thickness and it is flat, it means that it cannot fall over, of course. So it exists only on the flat surface of our paper. Now, there are some examples as we will come to learn in geometry. There are various kinds of two-dimensional shapes, but there are some shapes that you will always come across. We're going to learn about some of those shapes. Examples of such two-dimensional shapes are circle, which is a two-dimensional shape, triangle, square, rectangle, parallelogram, and trapezium. We'll look at each of these shapes one after the other. Let's start with our first shape for today, square. A square is a very exciting shape. It is a shape that has certain properties. A square is very noticeable because it has four sides, and those four sides are all equal in length. So this is an example of a square. It has one side, two sides, three sides, and four sides. So we have 1, 2, 3, 4. A square has four sides. And we said each of those sides are equal in length. That is what distinguishes a square from every other kind of shape. If, for instance, this our side here is what? 2 centimeters. It means that this second side would also be 2 centimeters. The third side will also be 2 centimeters. And the fourth side will also be 2 centimeters. When we draw a shape like this, we use this stroke here to show us that there is equality between all of these sides. So this side here has a stroke. This side also has a stroke. This side has a stroke. And this side also has a stroke. It means that this side, this side, this side, all of the sides are equal. So the stroke here shows equal sides. Let's look at another property of a square. A square also has 4 interior angles. Let's look at our square again. This is an angle. Now let's look again at our square. We said it has 4 interior angles. Interior means it is inside the shape. Interior, inside. All right? And these are the angles. We have one angle here. We have the second angle there. We have the third angle. And we have the fourth angle. So we have 4 interior angles within a square. Now, every angle in our square is a right angle. Whenever you hear the word right angle, it means that that angle is what? 90 degrees in size. So we have 4 right angles, and each of these angles are equal one to another, which means that if we add 90 to 90 to 90 and to 90, we would have 360. So the angle, or the total angle within a square, gives us what? 360 degrees in size. Again, this symbol here, which is a little square, by the edges of our shape, we find this little square as a symbol. When we see such a case, it means that there is a right angle on that, or by that edge. So we have this little square here by the edge of our shape, telling us that there is a right angle here. Right angle. So we have 1 right angle, 2 right angles, 3 right angles, and 4 right angles. And a right angle, we have length, is what? 90 degrees in size. 90 degrees in size. Lastly, the opposite sides of a square are parallel. The word parallel simply means that these opposite sides, of course, this side is opposite to this side. Again, this side is also opposite to this side. So it means that these opposite sides are parallel one to another. Parallel means that they are traveling in the same direction. We use an arrow to show that sides are parallel. So if you see this arrow, or you are told that these 2 sides are parallel, it means that they are traveling in the same straight line direction. And they will never come at any point to meet each other. They will always travel in a straight direction without crossing the path of each other. So that is what this word parallel means. Keep that in mind. As we go further, even in this class and in other classes, when you come across the word parallel, that's what it means. They never cross each other. They are always moving in a straight line, and they move on in that way forever. So that is what our square is. Now we've learned about square. Let's also learn about another exciting shape. The next shape we'll be looking at is the rectangle. Rectangle is another type of a 2-dimensional shape. Now a rectangle, just like our square, has 4 sides. So we have 1 side here, 2 sides, 3 sides, and 4 sides. So it's a 4-sided 2-dimensional shape. The opposite sides of a rectangle are equal in length. Of course, we know what opposite means. It means that our side 1 and our side 3 are opposite. Also, the side 4 and side 2 are also opposite to each other. We said that the opposite sides are equal in length. It means that our side 1 and our side 3 are equal in length. If we were to measure the side 1 to be 2 centimeters, the side 3 will also be 2 centimeters. Side 4, which is opposite to side 2, in a rectangle here, for instance, is also equal one to another. If we have 1 centimeter as our side 4, it means that our side 2 will also be 1 centimeter. So in a typical rectangle, we have a pair of opposite sides that are always longer. Remember, in square, we have 4 equal sides, where for the rectangle, a pair of sides are always longer than the other pair of opposite sides. So this side, for instance, is longer. And of course, this side is same as this side. This is longer, and this is shorter. Of course, these opposite sides are also equal. So this is equal to this, shorter than these sides, which are longer. That is how you know what a rectangular shape is. Next, every angle in a rectangle is a right angle. Just like we learned for the square. We have this small square as our symbol by the edge of our shape, telling us that we have right angles in this corner. So we have 1 right angle, 2 right angle, 3 right angle, and 4 right angle. Of course, the point we made earlier, that the opposite sides are equal, can also be explained using symbols like our stroke. So we have the stroke here, which is single, as we see on our shape. The side 4 and the side 2 have a single stroke. It's telling us that these sides are equal in length. Also, the side 1 and side 3 has double strokes. Because this side is different in length to this side, we do not use the same stroke. So we use double stroke to indicate a difference in size. So the double stroke, which is on our side 1 and our side 3, also tells us that the side 1 and 3 are equal in length. So we use strokes to also show that. While we use our small square box to also tell us that we have right angles. And lastly, just like our square, the opposite sides of a rectangle are parallel. So now we know what a parallel line is. Parallel lines are lines that are traveling in the same direction and will never at any point come to cross each other. Let's go on to learn about other exciting shapes. Now, another very exciting shape that we have as a two-dimensional shape is what? The triangle. Tri, of course, means 3. Angle, so it means it's a shape that has 3 angles. A shape that has 3 angles. Now, a triangle looks something like this. So we have this line and a horizontal line, all meeting up to form a triangular shape. So whenever you see a shape like this, at once you know that it's a triangle. A triangle has some certain properties. Number 1, it has 3 sides. It's unique because it's the only shape that has 3 sides. Other shapes have more sizes, maybe 4, 5, 6. As we go on, we'll learn about some of these shapes. But a triangle has 3 sides. So it's different from a square. It's also different from a rectangle that we've learned about. It has 3 sides. And like the name tells us, tri, an angle, 3 angles. It has 3 angles. We use this symbol, which is like a curve, around the edges of our shape to indicate angle. So we have a curve here, another curve here, and a third curve. So we have 3 curves. Of course, this curve at this edge of our shape here tells us there's an angle here, there's also an angle here, and there's an angle here. So we have angle A, angle B, and angle C. It has 3 angles. Now the size of these angles, if we were to add them up, they always sum up to 180 degrees. Remember when we looked at the square and the rectangle, we said the sum of their angles, which are all right angles, that is, they are all 90 degrees in size. If we sum up 90 degrees in 4 places, we would have 360 degrees. So it simply means that for 4-sided shapes, we have the sum of their interior angle as 360 degrees. Well, for a triangle, the sum of the interior angles within the shape is not 360, but 180 degrees. It's very important that you also know this. As you go further in the study of geometry, you'll know how to apply this knowledge. Let's again look at some other very important types of triangles. Now, depending on the size of the angles within our triangle, or even on the kind of side the triangle has. A triangle can be classified in different ways. We have different kinds of triangles. For instance, we have what we call scalene triangle. A scalene triangle has 3 sides, of course, that are all different in length. This is an example of what a scalene triangle is. It has 3 sides, like a normal triangle should have. But if we were to measure the length of a scalene triangle, say for instance, this could be 2 centimeters, this could be 5 centimeters, and this side is the longest side, will have like 6 centimeters. So a typical scalene triangle, based on the length of its side, has 3 sides that are all different in length. That is how you know a scalene triangle. Now also, we said that triangles can be classified by their size. We've seen an example. It can also be classified by their angles, or even a combination of both sides and angles. Now let's see a type of triangle that is classified based on the type of angle that it has. The right-angled triangle. As the name implies, a right-angled triangle contains one right angle. And of course, we've learned that one right angle simply means 90 degrees. So we have one angle in the triangle that is 90 degrees. This is an example of a right-angled triangle. This angle here is 90 degrees. So immediately we see a right-angled triangle, we simply look out for one of its angles. If it's 90 degrees, we immediately know that we have a right-angled triangle. Another kind of triangle that we have is known as the obtuse angled triangle. The word obtuse simply means that one of the angles of the triangle is more than 90 degrees. Remember, in explaining what 90-degree size is, we use a straight line and we had our little square to indicate. Well, an obtuse triangle, instead of being this straight line, which is the measurement of our line here to this side, we have a line drawn in that way. So our measurement goes more than 90 degrees. So we have like 91, 92, up to 100 and something, and so on. But as long as it is more than 90 degrees. Let's take an example of a typical obtuse angled triangle. So we see that there is no straight line here. Instead, our line is bent way beyond the straight line. This is an example of an obtuse angled triangle. And this is our obtuse angle, more than 90 degrees. So immediately we see such a triangle, we know that it's an obtuse angled triangle. Now, another type of triangle that we also have is the isosceles triangle. The isosceles triangle has 2 sides equal in length, and consequently, 2 angles also equal in length. This is an example of an isosceles triangle. Now, we've learned how to use symbols to indicate equality of sides or even equality of angles. These double strokes here on both sides of our shape tells us that this shape is equal to this shape. So this is an isosceles triangle that has 2 equal sides. Also, the sides, when they are traced down to meet our third side here, will give us 2 angles that are also equal. So if this is our angle A, it means that this angle also will be A. This is an example of an isosceles triangle. Next, we have what is referred to as the equilateral triangle. The word equi simply means equal. So it gives us an idea. Equilateral triangles have 3 equal sides. And of course, again, consequently, will also have 3 equal angles. This is an example of an equilateral triangle. Again, our stroke here is a symbol that tells us that this side is equal to this side, which is also equal to this side. So we have 3 equal sides. And it means also that we will have 3 equal angles. An equilateral triangle has each angle as 60 degrees. If we begin to remember those properties we listed, we said the sum of angles within a triangle should be what? 180. So if they are all equal, it means that each angle will be 60 degrees each. Another type of triangle that we have is what we refer to as acute triangles. Acute simply means sharp. Of course, acute triangles are triangles that are less than 90. Because they are less than 90, we have angles of this sort. And of course, our angle here, if we found out, will be less than 90. They have a sharp edge, hence the name acute triangles. Now, let's look at other kinds of shapes. We've learned all about triangles. Let's move on to learn about another 2D shape known as a trapezium. Trapezium. Trapezium is also another exciting kind of 2-dimensional shape. It has 4 sides, and it has 1 pair of its opposite sides to be parallel. This is an example of what a trapezium looks like. So we have 1 side, 2 sides, 3 sides, and 4 sides. But a pair of its opposite sides are what? Parallel. Now we've learned what this word parallel means. The opposite sides here would be 1 and 3. Now we have learned that we use different symbols to indicate some certain properties. The symbol we use to indicate the parallel lines in our shape is an arrow that we draw across the lines indicated. So we have line 1 and line 3 having our arrows like this. It tells us that line 1 and line 3 are parallel. That is, if we continue to draw them in that straight direction, they will continue to go without crossing each other. But the other lines, our line 2 and our line 4, are not parallel. If we, for instance, kept drawing this, at a point, of course, they would meet somewhere here. So this line 4 and 2, of course, are not parallel. But 1 and 3 are parallel. That is how we know a trapezium shape. Let's go on to learn also about the parallelogram. From the name also again, we have an idea of what this shape will look like. We're talking about parallel within the parallelogram. A parallelogram has 4 sides. So this is an example of what a parallelogram looks like. 1 side, 2 sides, 3 sides, 4 sides. But it is unique based on its name. It has 2 pairs of opposite sides parallel one to another. So side 1 and side 3 are parallel to each other, while 2 and 4 are also parallel to each other. So immediately you hear or you see the name parallelogram, you should have an idea that each pair of opposite sides are parallel to each other. And if we were to draw them, this is the way we would draw it. So these sides are parallel, while the other opposite sides also are parallel. We've learned to use symbols. So once again, we use our parallel symbol to indicate on the line. And we also have the opposite sides of a parallelogram to be equal in length. So our side 1 and 3, they are equal in length, while 2 and 4 are equal also in length. Side 1, for instance, and side 2 are completely different. And hence, like we've learned, we use 1 stroke, for instance, for sides 2 and 4, while we use 2 strokes for side 1 and 3, telling us that this length are equal, but different from side 2 and 4. And lastly, the opposite angles of a parallelogram are equal. So we have our angle here, of course, which we use our curve symbol to indicate that there is an angle. Our angle and its opposite angle here will give us B and B. So if we have 20 degrees here, it means that we'd also have 20 degrees here. While the opposite side also, if we have an angle A here, is also the same as A. And these are the properties of our shape parallelogram. Finally, let's look at another shape that is a two-dimensional shape, the circle. The circle is a very popular shape. It is round in nature. A circle is a simple closed plane shape. It is closed. It is a set of all points on a plane that is a fixed distance from a center. This is what we're trying to explain. If we have a center here, and we have a distance of maybe 2 meters or centimeters from our center. If we measured, for instance, our tape also to get a point here, and we kept doing that, all 2 meters, 2 meters, 2 meters. If we were to join all of our points here, that is, all the distances to the center equal to 2 meters, the shape we'll get at the end of the day is a circle. So a circle is the set of all points. These are our points. Points, 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 points. On a plane, remember a plane is a flat surface that does not, have a height, that are a fixed distance from the center. Remember, for instance, we used 2 meters, so it's a fixed distance. This is what we will get at the end of the day, our circle. Now, a circle looks typically like this. It's round and has equal distance from our center point. Now, a circle has different dimensions or measurements within it. Let's look at the first one, the radius. Very important in the study of geometry. Radius is one concept that we must understand. The radius is the distance from the center of the circle to the edge of our circle. The example we used here, for instance, remember we used a line that measured 2 meters to get our points. That line is what we refer to as the radius. So this is our radius. The distance from the center outwards, touching the edge of our circle. Another point we need to know is the diameter. The diameter is also a measurement of the distance across the circle that passes through the center of the circle. So it's the measurement of the distance touching the edges of our circle that passes through the center. So our diameter is this measurement from this edge up to this edge. Our diameter is twice the distance of our radius. So 2 times the radius will give us diameter. Always remember this. 2 times radius will give us our diameter. Also, the circumference. The circumference is simply the distance round the circle once. So imagine you have a round field. If you walked around the field one time and measured how far you've gone, you would have the circumference of the field. So our circumference is the distance round your circle one time. That is the circumference. Now, the center of our circle, we've already learned, is the very middle of the circle. This is our center from the example we drew. From the center, we measured out our radius to get the circle. There are also other concepts that we need to know about the circle. Now, if we have a circle and we have a radius, which we've learned about, the radius, if measured in this direction, and we have another radius also off from the circle, the distance along our curved path from this edge here to our edge here is what we know as the arc. It is the curved path along the circumference that we measure at a point of radius that cuts our circle here. This is the arc. Also, the chord is a straight line that joins 2 points on our circumference. Remember, we said the circumference is the distance around the circle. The chord is simply this line that joins 2 points. So if we have a point here on the circumference of our circle, we have another point. The line that we draw is what is referred to as a chord. A sector is the region between 2 radii and the circumference. So a sector is the region that is all the content within this region here. So if we have a radius, R here, and we drew another radius, all the contents within the intercept of our radius along the circumference down to the center of the circle, all of this region is what we refer to be a sector. Also, we have a segment. A segment is the region between a chord and the circumference. Remember, we drew a chord here as the line. The line, this line is what we know as a chord. This line is a chord. This line here. All right? Now, the region that this line maps out, if we measured out from our circumference and the borders of our chord, would have what we have to be a segment. And finally, a semicircle. A semicircle is simply a full circle that is cut in half. And if you cut a circle in half, the lower part, you have 2 parts. Each part is a semicircle. 2 semicircles will make up 1 circle. So we have our semicircle here. It is a sector between the diameter, this is our diameter, and the circumference. This is our circumference. So all the content or the region between our diameter and the circumference will give us a semicircle. Or simply half of a circle gives us a semicircle. So now we've learned about a circle and the different ways a circle can be mapped out to give us things such as arcs, chords, sectors, segments, semicircles, diameter, radius, and the others. Now, all of these shapes that we've learned about so far, they can be grouped into different groups. And one major group of shapes is what we know as polygons. It's a Greek word, poly and gon, meaning many angles. So it's simply shapes that have many angles. It is a closed, plain 2D shape with 3 or more straight sides. A polygon. When we say closed, it simply means that all the lines, they connect up. So we have 1 line, 2 lines, 3 lines, 4 lines. And they all connect up, so it is closed. Again, it is a 2D shape sitting on a plane. That is, it is flat on a flat surface and has no height. It has 3 or more straight sides. That is what a polygon is. Now, what are some examples of polygons? We said it has 3 or more straight sides. It means 3 sides. Remember, triangle has 3 sides. So examples of polygons would be triangles. Other shapes that have 4 sides that we've learned so far: squares, rectangles, parallelogram, trapezium. They all have 4 sides. So 3 or more would include triangle, and all of these shapes, inclusive of shapes that have 5 sides, 6 sides, and the likes. We may not dwell on that, but we can also learn quickly some shapes that have 5 sides. A shape that has 5 sides is called a pentagon. Pentagon. It has 5 sides. 1, 2, 3, 4, 5. Pentagon. A shape that has 6 sides is called hexagon. It has 1, 2, 3, 4, 5, 6. A shape that has 7 sides is called heptagon. And so on. We get the idea. We'll draw the shape. If we drew it, we'd have 1, 2, 3, 4, 5, 6, 7. 7 sides. 8 sides has septagon. 9 has nonagon. And 10 has decagon as a name. All of these shapes are all polygons, because we said a polygon is a shape that is 2-dimensional. It has 3 or more straight lines. So as long as our lines are straight, and even if they are 3 upwards, they are considered to be what? Polygons. Now, a polygon can also be classified as regular or irregular. A regular polygon is a polygon in which all its sides are equal in length. Not just the sides being equal, the angles within those shapes are also equal in length. Let's quickly think, among the shapes we've learned so far, which among them is a regular polygon? Equilateral triangle is a regular polygon. Why? It has 3 equal sides, and also it has its angles equal to one another. The square also is another example of a regular polygon. And then we also have regular pentagons. It means that our pentagon here must have all its sides equal. And if its sides are equal, it also means that the angles within it will be equal. Regular hexagon, also 6-sided, all sides must be equal and hence angle equal, and so on and so forth. So for a shape to be a regular polygon, it must satisfy this condition that the length must be equal in size and the angle must also be equal in size. Another classification of polygons are the irregular polygons. Of course, they are the opposite of our regular polygons. The sides are neither equal to another, neither are the angles equal also to another. In this class, we will not dwell on irregular polygons. So we'll be learning only about regular polygons. Now, shapes can also be classified in another way. Let's learn about that. Now, polygons, like we've learned about, are also further divided into another class of shapes, which we call quadrilaterals. A quadrilateral simply means a 4-sided shape. So a quadrilateral is a 4-sided polygon. So examples of those shapes that fall into the category of quadrilaterals are squares, which has 4 sides, rectangles, which has 4 sides, parallelograms, and trapeziums all have 4 sides. Now, to to summarize all we've learned today, let's take a recap. We learned about points. We said points have no dimension, but they have a position. We also learned about the lines. We said lines are one-dimensional in nature. Next, we learned about planes. We said planes are two-dimensional in nature. Remember, we said they are on a flat surface that have no thickness or height. Next, we learned about plane shapes. We said a plane shape is any shape that is two-dimensional, that is, it has length and breadth, but has no thickness. An example of some plane shapes that are two-dimensional are squares, which we learned about, rectangles, parallelograms, circles, trapeziums. We also learned what a polygon is. We said a polygon is a closed 2D shape that has 3 or more straight lines. And we said examples are rectangles, squares, triangles, and so on. We said further that polygons can be regular or irregular. When they are regular, it means that each side is equal one to another, and the angles within the shape are also equal. We gave examples as equilateral triangle. We also gave other examples as square. Next, we learned about quadrilaterals. We said quadrilaterals are polygons that are four-sided in nature. An example of such quadrilaterals are squares, rectangles, trapeziums, and parallelograms. Now, for all that we've learned so far, we're going to test ourselves. We're going to give ourselves 2 quick questions to see how much we have learned. A plane has how many dimensions? A, it has no dimension. B, it has 1 dimension. C, it has 2 dimensions. And D, it has 3 dimensions. The correct answer is C. A plane has 2 dimensions. Now let's take our next question. Quadrilaterals are polygons that have dash number of sides. A, 3 sides. B, 4 sides. C, 3 or 4 sides. D, 4 or more sides. Quadrilaterals are polygons that have dash number of sides. Our correct answer is B. Quadrilaterals have 4 sides. With that, we've come to the end of our class for today. I'm sure you had so much of a nice time, and I hope to see you in my next class. For me, it's bye for now.